All right, super pilot, you are good. In fact, you are so good that you already know all about precision approaches. Those are the approaches with vertical guidance like the glide slope on an ILS. So now that you have that figured out, let's explore non-precision approaches. Those are the ones that do not give you vertical guidance, like a localizer-only approach. That's a good example of a non-precision approach. Well, after you've mastered the ILS approach, you'd think flying a localizer-only approach would be an absolute snap. After all, you're used to tracking 2 needles, and now you're only tracking 1 needle. Well, that's true. But on a localizer-only approach, you have to manage your own descent instead of having an electronic glide slope lead you down. Now, other than that, you will be using a lot of the same procedures and techniques that you already know from the ILS approach. And by the way, there are several reasons why you might have to fly a localizer-only approach. First of all, the glide slope transmitter for the ILS at your destination airport might be inoperative, or the glide slope receiver in your airplane may have failed, or you might be flying an airplane that doesn't even have a glide slope receiver installed in it. But really, more likely, the approach may have been designed as a localizer-only approach to begin with, and that's a non-precision approach. And that happens when the terrain around the airport or money limitations make it impractical to install a glide slope transmitter. Now, as an example of a localizer-only approach, let's take a look at this approach right here, the localizer runway 17 approach to Leesburg Airport. Now, when you brief yourself and set up for the approach, you'll find that there are really only 2 differences between a localizer approach and an ILS approach. First, instead of having a glide slope for your descent guidance, on a localizer approach, you descend in a series of steps to specific altitudes as you cross fixes. So on any non-precision approach, a profile of the flight path looks like a series of stair steps. Well, not surprisingly, a fix that tells you when it's safe to descend to the next lower altitude is called a step-down fix. Eventually, you arrive at the lowest altitude permitted for the approach, and that's the minimum descent altitude, or it's often called the MDA. Now, you cannot go any lower than this altitude until you have the runway environment in sight and you're in a position to make a normal landing. Now, the second difference between a localizer approach and an ILS approach is how you determine the missed approach point. Now, as you recall, when you fly an ILS, you follow the glide slope down to decision height. And if you don't see the runway at decision height, you immediately execute the missed approach procedure. Well, on a localizer-only approach or any other non-precision approach, you'll be flying level when you get to the MDA, and you're not using that glide slope. So you need some other way than your position on the glide slope to know when you've reached the missed approach point. Well, on a localizer approach, the missed approach point is normally either a DME fix or it's based on timing from the final approach fix to the missed approach point. Now, you'll have to examine the approach chart to know how it's defined for each approach. Now, let's see how all of this works out for the localizer approach at Leesburg. And you already know how to self-brief an approach, so we'll just hit the items that make it different from an ILS approach. Well, to start with, the title to the approach says LOC, meaning it's got a localizer but no glide slope. And the plan view looks very much like an ILS. Notice the big localizer symbol here. And over here you see the still and ward fixes. By the way, those are step-down fixes for the approach, and you could identify them by DME distances or by cross-bearing or bearings from a VOR. For instance, still can be identified by the 11.2 DME fix from the localizer transmitter, or it could also be identified by the 238 radial from the, in this case, Frederick VOR, or also the 137 radial from the Martinsburg VORTAC. Ward is the 5 DME fix from the localizer transmitter, or the 220 radial from the Frederick VOR. Now let's take a look at the profile view. Now, your minimum altitude until you cross Still is 3,000 feet MSL. And then once you pass Still, you can descend 1,800 feet en route to Ward intersection. And you can tell, by the way, that Ward is the final approach fix because it's marked with this X, or called by people in the know the Maltese cross. And this is where you'll start timing from to determine your missed approach point. Now, notice that this approach uses an intersection for the final approach fix, but many localizer approaches will have an outer marker there. Now, once you're past Ward, you can descend now to 1,100 feet. Now, notice that past Ward, there's yet another step down fix, the 3 DME fix right here, but there's no altitude shown after you cross it. And the reason is that your minimum descent altitude may vary depending on your approach speed and whether or not you need to circle to land. So you have to go to this minimum section to find your MDA. Now, in the first part of the minimum section, you can see that for a Category A aircraft like your Skyhawk, flying a straight-in approach, you need at least 1 mile visibility, and your minimum descent altitude is 1,100 feet. Now, if you do not have DME, 1,100 feet is the lowest you can go. But if you do have DME and can identify this 3 DME fix, you go to the second part of the minimum section where it says DME minimums. And if you can identify that 3 DME fix, your descent altitude, minimum descent altitude, will be 720 feet for a straight-in approach. And if you do have that DME equipment, your missed approach point, shown in the profile view, will be the DME reading of 1.1 miles. Now, you know that that's the missed approach point because that's where this dashed arrow, which represents the missed approach path, starts its pull-up. Now, the Skyhawk 172R does not have a DME, but it does have an IFR certified GPS. So you can just substitute the GPS for DME, right? Well, yes, but not by selecting the airport as a named waypoint. Because as you already know, when you're using a DME associated with the localizer, the distances that DME shows you are from the localizer transmitter, which is off the far end of the runway here, and they're not from the airport reference point, which is near the center of the runway complex. So to use your GPS as a substitute for the DME with a localizer, you have to select a named waypoint like Ward and then calculate the distances from there. And by the way, calculating these distances in advance is something you should do during your approach self-briefing. Now, in this case, the profile view shows that the step-down fix is 2 miles from Ward, and the missed approach point is another 1.9 miles from Ward for a total of 3.9 miles from Ward. Now, when we talk about this approach, let's assume that we are flying this approach without either DME or an IFR certified GPS. In that case, your minimum descent altitude will be 1,100 feet MSL. And you determine the missed approach point based on the time it takes to fly from the final approach fix to the missed approach point. Now, let's check out the table under the airport diagram, and it says that distance from the final approach fix to the missed approach point is 3.9 nautical miles. And you find your approach speeds here. Let's say it's 90 knots in our case, and the time it would take you, in this case, 2 minutes and 36 seconds. Now, what if you had a headwind and your ground speed was significantly different, say around 80 knots. Well, in that case, you could just interpolate between 60 knots and 90 knots, or if interpolation is not your big deal, you could whip out your trusty old whiz wheel and calculate at 80 knots for 3.9 miles, and you get about 2.9 minutes, which would be about 2 minutes and 54 seconds. Now, you want to make sure that your results are reasonable and that the times come out somewhere between the times for 90 knots and 60 knots and make sense to you. Well, that pretty well takes care of the design differences between a localizer approach and an ILS approach. So let's see how you'd set up your nav radios for this approach. Now, setting up your navigation radios for any localizer approach is just about the same as setting up for an ILS approach, except that with a localizer approach, you'll need to use your number 2 nav to identify one or more of those step-down fixes. So let's take a look at how you would set up your navigation radios for this approach, the localizer runway 17 approach at Leesburg. Now, first of all, and always most important, make sure that you have the nav GPS switch set properly. In this case, you want it set to nav. Then set your number 1 nav to the localizer frequency. In this case, that frequency would be 1.75 and transfer that over. Now you'll want to put RML Vortac, which is frequency 113.5, in the standby because you'll need that in case you end up doing a missed approach. Now your number 2 nav is important because you will use it to identify those step-down fixes. Now in this case, let's assume that you're flying the transition from Martinsburg Vortac. In that case, you would already have Martinsburg's frequency set in the active position, and you'd be using that to track the 137 radio with the number 2 CDI. Now put the Frederick VOR in the standby position, because once you're established on the localizer inbound, you'll use Frederick to identify the cross bearings for those step-down fixes. Now, if you did have a GPS, you would set Ward in as your active waypoint, and you'd use that to determine your final approach fix, and you'd use it to calculate your step-down and missed approach fixes. But once again, we're assuming that for this approach, you don't have a GPS. Now, in this case, you won't need to set up marker beacons or ADF either, because there's nothing on this approach plate that they can work with. Now let's cover how you'd fly that approach. Now you already know how to fly a localizer, so let's concentrate on making the descent and identifying the missed approach point. Now in this case, when you intercept the localizer, you'll be at still, and that's the first step down fix. So once you're established inbound, it's time to start down to 1,800 feet. Now you'll have 6.2 miles to lose, we'll see, 1,200 feet here at 90 knots and without allowing for wind. That'll take you just about 4 minutes. You know, you could do this easily with a 300 foot per minute rate of descent, so you'll have plenty of time to make a normal 500 foot per minute rate of descent. Now, as soon as you start that descent, switch your number 2 nav over to Frederick VOR and then set the 220 radio on the number 2 OBS so you can identify Ward. Now, you'll know when you're at Ward when the number 2 CDI centers. Now, crossing Ward, which is the final approach fix, triggers those 5 T's, and they are time, turn, throttle, tune, and talk. First, start the time, and you'll need this time to be accurate so you'll know when you've reached your missed approach point. Now, if you were using a GPS, this time would just be a backup to the GPS. Now, there are no turns to make anywhere in here, so you can skip turn, but you should now throttle down to about 1,200 RPM or so and pitch down to start, in this case, an 800 foot per minute rate of descent. Now, we'll talk about why we recommend 800 feet per minute through here in just a little bit. Now, you've already tuned all the radio frequencies, and you don't need to set any more cross radials in. So when you have time, talk. Just switch 122.8, which is the Unicom frequency, from the standby to the active position, and then announce where you are. Now, once again, notice that on a non-precision approach, when you're on your descent to the minimum descent altitude, we recommend an 800 foot per minute rate of descent. Now, the reason for that is on a lot of non-precision approaches, if you wait till you get to the missed approach point before you begin your final descent to the runway, you won't have room to make a normal descent and a landing. So it pays to get down early so you can get below the clouds and spot that runway environment in plenty of time to make a normal descent and landing. Now, the 800 feet per minute that we recommend will get you down soon enough to do just that. Now, during the last 500 feet of this descent, we recommend you slow your descent rate to about 500 feet per minute. And during this time also, it's a good idea to start calling out your altitude in 100 foot increments. This keeps your altimeter in your scan and your MDA in your mind. So in this case, you might say there's 1,600 for 1,100, and there's, and when it gets there, 1,500 for 1,100, and so on until you level off at your MDA. Now, when you're shooting an approach where time determines your missed approach point, it's very important to hold your speed as constant as you can, and that's not always easy because you'll be descending, then leveling off, then descending again and leveling off, usually several times. But if you don't hold your speed constant, you'll end up starting your missed approach either before or after you reach the actual missed approach point. So hold your speed constant and watch your timer until, in this case, 2 minutes and 36 seconds runs out. And then if you don't see the runway environment or you aren't in a position for a normal descent and landing, execute the missed approach. Now, even though localizer approaches are called non-precision approaches, they'll give you very accurate course guidance to the airport. And being able to do them well will give you one more tool to make reliable arrivals even when the glide slope is out of service.